Hello and welcome to EE233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at one of our sorting algorithms. This video is meant to be part of a series of videos that are going to look at our sort demo and look at various algorithms for sorting, as well as a couple of applications of one of them. So to begin with, you'll notice that I have, in addition to my .c file open, I also have a sample file. Make sure that you can put your hands on a sample file. It doesn't necessarily have to be this one, but the idea is that you would have roughly around 100 pieces of data. And in this case, I have values ranging from 60 to 99. Now, the idea here is that we want to read in the contents of this file into an array, and then we want to sort the array either in ascending or descending order. If we sort in ascending order, it merely means that we go from smallest to largest, and the descending would be largest to smallest. Now, you'll notice here that I already have quite a bit of code for us. As a matter of fact, I've made some changes so that if you have an earlier version of this file, you probably want to pause the video for just a second to make sure that all of your variable names match, as well as the data types for each. Of particular difference is that I have decided to use the found variable. So the logic is going to be a little bit different than the older versions of this file. Additionally, you should also be able to get your hands on a .m or MATLAB equivalent of this particular sorting algorithm. So what we want to do is we want to just simply read in the file. And to start with, we open the file. We then use fscanf. Notice that it is %d. So we're assuming then that we have integer values in the file. And then we close the file once we have ran out of items to read in the file, or we have 100 values. So notice here that I've specified that the count underscore max is simply equal to 100. That is completely arbitrary. I just wanted to make sure that we only had 100 values so that ultimately we can do a comparison in our sorting algorithms. Now, the other thing to notice here is that I have not written in any logic to check to see whether the input file was successfully opened. So this assumes then that your sample underscore o1.txt resides in the same directory as your executable, or that you provide the correct path. Now, moving forward, you'll notice, and we're going to skip over some comments here, but you'll notice some additional code that deals with writing the output. So the idea here is that once again, we're simply going to read in our sample file, we're going to sort it, and then we're going to write the output to a second file. If you notice that we are allowing for a input file name and an output file name as parameters in our sort function. So the idea here is that you would pass the file name arguments to the function. It would read in the contents of one file, sort it, write it out. The third argument is the order, and this allows for us, through the use of an enum, to be able to specify whether we want to have ascending or descending. So without further ado, let's jump into actually writing this. In this particular example, what we're going to do is we're going to look at neighboring values. And essentially what we're going to do is go through the contents of the file. We're going to load it into the array. And so we're going to go through neighboring values in the array. And if we're focusing on ascending, basically, if the first value comes before the second value, no changes are made. However, if the first value comes after the second value, you switch the location of those two values, or rather you switch the value location. So in other words, you put the second value in the first location and you put the first value in the second location. And you repeat this all the way through the array until you get to the end of the array. If there were any changes made in the locations of any of the values in the array, you repeat the process. And so you start back over at the beginning of the array, once again, comparing neighboring values, and you continue to do this over and over again until there are no changes made in the array. So the first thing that we're going to want to do is use some of these variables that we have specified up here. And as a matter of fact, this would probably be a really good time to pause the video and just verify that you have the right variables as well as the right data types in case you're using an earlier version of this file. But inside then, or here where I've specified to do something with it, in other words, your code goes here, here is where we are going to implement this specific sorting algorithm. And essentially what we're going to do is we're going to compare neighboring values and switch them if necessary. And then repeat until done. And what we're going to use to be able to determine when we are done is going to be a variable called found. And found simply means that we found some value that needed to be switched. So to begin with, what we want to do is we want to set found equal to true. We're simply going to assume that we have something in our array that is out of place. Now that may turn out to be wrong, but that's going to be the initial assumption. So initially assume that something is out of place. And what this does then is this allows for us to be able to build a while loop. And so we say while found is equal to true, or found is equal to 1, we want to compare the neighboring values. And specifically, what we want to do is we then want to use a for loop to loop through each one of the values in the array. Now, we could do this with a for loop or with a while loop, doesn't really matter. But the first thing we want to do then is we want to start off by initializing our found, or reinitializing our found equal to 0. Okay, so in other words, no value has been found that needs to be moved. And if we use a for loop, then we don't have to worry about initializing our index. Otherwise, what you want to do is you want to initialize your index prior to starting your loop. So in this case, what we'll do is we can once again use either a for loop or a while loop. We're going to go ahead and initialize our index equal to 0. And what we're going to do here is simply say while index is less than count. Now, inside of the while loop, we simply then increment our index. So the first thing that should bother you here is the fact that that would mean that you essentially have 100 items to compare. But then the 100th item, or that very last item in the array, would have nothing to compare to. So instead, what we want to do is we want to specify index less than count minus 1. And if you recall from looking at the earlier code, the count keeps track of the exact number of rows that were read in from the file. So basically, if we were to read in 100 rows into our array, we would want to stop when we hit the 99th row so that we can compare then the 99th row with the 100th row. So what we want to do here is then inside of the while loop, we simply have an if statement that compares neighboring values. And so what we're going to do is we're going to use our unsorted chunks variable. So we want to say unsorted chunks, square brackets, and we compare the value at the location specified by the index, and we want to check to see if that value is less than unsorted chunks, square brackets, index plus 1. And if that's the case, in other words, if the first value is less than the second value, if we were interested in ascending, then that would simply mean that no changes were needed. Assuming ascending. Otherwise, under the else, then we would switch the two values, or we'd switch the values. Now, the only thing that we need to decide is what happens when the values are in fact equal. In other words, if we want to change the order of two values that are equal? And the answer to that is there's really no need. Okay, so in other words, if it is less than or equal, then if we're dealing with ascending, then that simply means that the lowest value already comes before or earlier in our array. So to switch the values, then we actually have a three-step process. The first step is that we want to use the temporary variable that we have specified earlier to store the value at one of the two locations. And it doesn't matter whether you store the first value or the second value in the temp variable, but you need to store one of the two values. The other thing to note briefly is the fact that the temporary variable data type has to match the data type for our array. And so in this case, what we will do is we would simply say temp then is going to be equal to the unsorted chunks. And I'm going to use the first value. So I'm going to assign then the first value to the temporary variable, which then allows for me to put the second value in the first value's location. So in this case, unsorted chunks, square brackets, index will now be equal to the unsorted chunks, square brackets, index plus 1. And so essentially what this does is this copies the second value to the first location. And then the third step is then simply to take the value that we stored in the temporary variable and put it in the second value's location. So to do that, we simply say unsorted chunks, square brackets, index plus 1 is now equal to temp. The last thing that we want to do as part of this is simply indicate that we have in fact found a value that needed to be moved. And so in this case, what we will do is we simply specify that now found is equal to 1. So we found a value that needed to be moved. And then either way, we simply increment our index. Now, early on, I mentioned that we have an additional input argument up here, and that is the order. But we really didn't deal with it when we were talking about the logic. And the reason for it was I didn't want to confuse the issue. And so instead, what I want to do now is I want to look at how we would change this depending on whether it was ascending or descending. The reality of it is, the only thing that really changes about this algorithm is then the inequality. So what we'd like to do briefly is go ahead and insert an if statement that will handle whether it's ascending or descending. Now, the question becomes, where do we insert that if statement? If we insert it outside of the while loop, it means that we check the order only once. And if you note, the order cannot change, or at least we're not changing it once it's being passed to our sort function. So if we put our if statement outside of the while loop, we would check the order exactly once. However, we would wind up with a significant amount of duplicate code. We could also put the if statement inside the inner while loop, and at that point, we would be checking the order every time. But since the order never changes, we would be unnecessarily checking a variable. So in this particular case, we're going to accept that we're going to have a little bit of code redundancy in lieu of over checking a variable that will never change. Put another way, I'm going to put my if statement outside of my while loop. And so basically, after we have initialized our found, we simply check to see if order is equal to, and in this case, what we want to do is we want to use our order enum. And if you right click on the order enum and go to definition, you'll see that our options are ascending or descending. And so if you scroll back down here, then what we will do is we'll check to see if our order is equal to ascending, else if our order is equal to descending, and then else. Well, theoretically, there shouldn't be any other options that we would be adding to this. However, you do get into a good practice, or you should get into a good practice of identifying all of your enums, and then under the else, simply include a printf that simply says error unhandled enum. And that way, if you do, for instance, write code in the future that would leverage another enumerator that you have not yet handled, it is easily identified. Whereas if you simply do a if else, everything that was not ascending would simply be lumped into the else. So once again, this is a good pattern to get into. In this particular case, it's going to seem like a little bit of overkill. Now, what we want to do is we want to very carefully move our nested loops here, our nested while loop. So I'm going to Control X, and I'm going to put it inside of our true branch, or in other words, the if part of our if else. And we're going to put the duplicate code now under the descending, with the main difference being that we simply switch our sign now from less than or equal to greater than or equal to. So in this case, what this is going to do is this is going to allow for us then to handle descending. So in other words, if the first chunk, or the one that's located at index, is greater than or equal to the second chunk, essentially we do nothing. All right, so let's see how well this works. So just a quick review. The goal is that we are going to read in the integers into our text file. Using this simple while loop, we close the file. Now we're going to do something with it. And essentially doing something with it means that we're going to be comparing neighboring values. If, in this case, if we're looking at ascending, then for neighboring values, if the first value is less than the second value, we do nothing. Or if they're equal, we do nothing. In any other scenario, we simply swap them by assigning one of the values to a temporary variable, assigning the second value to the first location, and then assigning that temp value back to the second location. Trip our flag. In other words, we say found is equal to true or 1, and repeat the whole process over and over again. Now, you're probably wondering, how do we ever get out of our outer while loop? Well, eventually what will happen is that you are going to continue to swap the neighbors until ultimately they are in the correct location. In other words, you'll make a complete pass through the inner while loop without ever finding two neighbors that need to be changed. At that point, found will never be changed from 0 back to 1. And as a result, you're going to get kicked out of the while loop. This should then trigger you to note that this particular approach will run at least once more than is needed, meaning that essentially that last pass is simply a verification pass. So if you think of an analogy of having a room full of people all in a line, and every person asks their neighbor what their last name is. And if you want to do it alphabetically, you would assume then the A's would come before the B's and so on, that essentially the first person would swap with the second person only if their name came after the second person's name in the dictionary. And then finally, once that has been done multiple times, then effectively that last time would be the validation that everyone in the line is in the correct place. At that point, and only at that point, will found be equal to 0 and therefore escape out of this outer while loop. So let's see how we did. I'm going to go ahead and save this. I'm going to go ahead and come up now to our main. And much like in some of our earlier videos, I want to leverage our argc and an argv for this demo. And particularly what I want to do is I want to provide a sample input file name, a sample output file name, and I also want to specify whether or not it's supposed to be ascending or descending. So in addition to the executable name, as well as specifying which version of our sort function we want to use, we are going to have 3 additional arguments. So in total, we're going to be looking at argc, or our argument count, equal to 5. So the first thing we want to do is we want to utilize our if statement to check to see if argc is equal to 5. And we also want to check using our string compare I. We would like to see then if our argv square brackets. Now, remember that the 0th argument is the executable. So we're looking then at the first switch so that argv square brackets 1. We want to then compare that to see if it matches our sort underscore version 2. And once again, I'm simply going to use the function names as my switch names until that becomes a problem. And if that matches, then what we're going to assume then is that argv2 through argv4 are going to give us some information about the input files and the output files. So what we want to do is we want to create a couple of temporary variables here. Just for clarity's sake, you don't technically have to have them. But what I want to do now is I want to have a input file name. And I'm going to assume that we're going to max out at 20 characters. There really shouldn't be much of a need to have a file name that's longer than that. And we're also going to have an output file name, and we're going to assume that it is 20 characters. And then the third one is going to be the order. But the order, interestingly enough, is going to be a character and not an enum. And so what I'm going to do here is I'm going to specify that it can be up to 20. However, that's going to be excessive, and you can actually determine the exact number of characters just simply by counting the number of characters in these enum names and then adding 1. So what we want to do now is, using string copy, we want to simply copy then the contents of our argv to the appropriate variable name. So in this case, we're going to assume that then our input file name is actually coming from argv square brackets 2. We're going to assume that our output file name is coming from argv square brackets 3. And lastly, we're going to assume then that our order is going to come from argv square brackets 4. So order and then argv square brackets 4. Now this is where it gets a little bit interesting, because we cannot directly convert a string into an enum. Instead, what we want to do is use a little bit of logic here. And that logic is going to come in the form of another string compare I. And so we want to compare the value in our order, or in our argv square brackets 4, and we want to compare it to the word ascending. And if that in fact equals 0, in other words, if there's a match, then we simply want to call our sort function using the ascending enum. Well, likewise, we want to do an else if using, once again, our string compare I. And we want to compare the value in the order string or order character vector. And we want to compare that now to the descending string. And if that's equal to 0, we simply call our sort function using the descending enum. And then lastly, under the else, we simply want to make a call to our help function. Now, we haven't had a chance yet to update our help function, so we'll take a second to go ahead and put one in here. So in this case, to keep consistent with our earlier videos, we're going to return nothing from our help function, and we're going to accept no input arguments. So we're simply going to come down here to the bottom of our file, and we're going to toss in then our help function. And we're simply going to follow the same pattern using the printf and usage, followed by a new line, and then underneath give examples for using our switches. So in this particular case, the way that we would expect this to be used is going to be sort underscore version 2, followed by whatever the file name. In this case, it's going to be sample underscore 01.txt. And for a couple of examples here, I'm going to have ascending .txt, which is going to indicate that the output was in ascending order. And more specifically, I'm going to use ascending to indicate the sort. So this ascending.txt represents the output file. This ascending simply specifies what value is going to be passed to the function. Likewise, what we would do here is we would have sort v2 sample underscore 01.txt. In this case, we may have a second output file called descending.txt. And then to specify the order, we would simply specify the string name for the enum. And those would be examples of calling our executable. Which brings us back to what happens in main if the argv square brackets 4 doesn't match either ascending or descending. We simply want to present the help. Now, we've written the pseudocode. How do we actually do this? Well, fortunately, this isn't too bad. So we can create a temporary variable, int results. And if you recall, we didn't really do a lot in our sort v2 with our return value. We simply return exit success, which is perfectly fine. One of the things I would consider doing here is maybe returning the number of swaps that were made. That would actually be kind of useful, but we'll pick that one up then in another video. But rather what we want to do is we simply want to say results equal to now sort version 2. And I want to pass now that input file name for the first input argument, my output file name for the second argument, and now I have to essentially convert that order string over to an enum, in which case what I want to do now is I actually want to specify ascending, not a string ascending, but the enum ascending. And so to do this now, we also want to do the same thing for results equal to sort v2 for the input file name, output file name, and descending. Okay, and a little typo here, nothing to worry too much about. But hopefully you see now how we can essentially convert a string that would be passed as a command line argument into a useful enum here. And in this particular case, then, if we didn't pass a correct command line argument for argv square brackets 4, we simply call the help. Now let's build this. Let's see if we've got any compile errors. Looks good. The next thing that we want to do is we want to make a copy of that sample underscore 01.txt, and we want to go into our distribution, into our debug folder, into the MinGW Windows folder, and we want to find our sort demo, and we want to paste the file in the same folder. If you do not do this, then your application is going to crash, because if you recall, we did not put any logic in here to check to see if there was a null file pointer. All right, so let's come out here to the console now. We'll do dir. You see there's our sample 01.txt and our source demo, or sort demo rather. So let's go ahead and run our sort demo, with the first switch being sort underscore version 2. For our input file, we simply want to specify sample underscore 01.txt. We don't technically have to follow the help here. As a matter of fact, I'm intentionally going to use a different file name here. So in this case, what I'm going to do is I'm going to call it sample underscore 01 underscore ascending. And I'm going to specify it with the .txt file extension. So hopefully you see that there isn't necessarily any correlation between the file name and the enum other than convenience. And then for the final argument, I simply want to specify ascending. Now, if I hit enter, don't worry too much about this loop counter version 2 saying 0. We'll come back to that in a later video. We're essentially going to compare our different sorting algorithms in an attempt to quantify which one is the most efficient, but more importantly, if we do a dir here, you'll notice that my sample underscore 01 ascending.txt has 0 bytes in it. So we appear to have a problem. So we'll come back here real quick and we'll see if we can figure out what went wrong. So the first thing that you would want to do in this particular case is start off with what I refer to as a sanity check. And I've already put one in here for you in that I have a printf that simply prints out the values as they are read in from the file. So the first thing that we want to do is simply uncomment that, go ahead and build it, and then come out to the command line and rerun it. And so we see here that for whatever reason, we are not even opening our file. And so what we've got to do is figure out what's going on here. So basically we are not triggering our while loop here. So it turns out that with a little bit of debugging, you'll discover what the problem is. And so I have made no changes to my code, but instead what I'm going to do is I'm going to go ahead and put a breakpoint at the top of line 223, or the top of my function rather. And then inside of our sort demo, we want to go to properties, and under the run tab, you want to simply put in the switches that you would have otherwise entered in from the command line. You also want to change the internal terminal to external terminal and hit apply. Now, essentially what's going to happen is when we debug our executable, the same switches that would have been passed to the command line by us are now passed by NetBeans to the executable, so that when we hit debug, the same switches are going to be triaged, and we will ultimately be passed to our sort version 2. And now we are inside of our function, which allows for us then to either use the variable tab or the expression evaluation to check what the values for the input file name and our output file name are. Now, if you can see what's in the expression evaluation, that looks strange. And the reason it looks strange is because we should see sample underscore 01.txt for our input file name. Instead, what's happening is that we are somehow overriding the input file name in the process of collecting the information from the command line or passing it to the function. So what we're going to do to see what the problem is, I'm going to go ahead and stop debugging. And I'm going to come out here to main, and instead I'm going to put a breakpoint on line 47, and I'm going to run the debugger one more time. This time it's going to stop us earlier in the code before we ever get to our sorting function. And I'm once again going to use the expression evaluation to check what my argv0 is. Of course, that's the executable. My argv1 is the switch that indicates that I want to run the sorting function version 2. My argv2 is my sample 01.txt. The argv3 is my output file, and argv4 is the string that corresponds to the sort order. So far, so good. So let's check what these temporary variables look like. So in this case, input underscore file name looks good, or does it? Well, there is that txt one more time. And our output file name is equally goofed up. And at this point, you should probably have figured out what the mistake is. If not, I'll give you a hint. Earlier in the video, I said 20 characters should be enough. Well, in fact, in the example that we provided in the command line, it wasn't, because if you add up the length of this file name, you'll discover that it is too long. So we've got a couple of things we can do here. Of course, we can stop debugging now that we have a pretty good idea of what the problem is. And then what we can do now is we can either increase the size of our input file name and output file name, or simply when we are demoing it, use shorter files. And so what I'd like to do is I'd like to actually keep my file name. So I'm just going to use a little bit more memory here. I'm going to up this to 30, and the 20 for the order is perfectly fine. I'm going to build it. And let's go ahead and run it. And now you'll see that not only do we get the last line that has the loop counter version 2, but we still get the printf that we earlier uncommented. But more importantly, if I type in dir, you'll notice that my sample underscore 01 underscore ascending.txt no longer has 0 bytes in it. So let's take that and let's drag it into NetBeans and let's take a look at it. And sure enough, it starts off with 60 and it ends at 99. Let's test this one more time with a different file name. Of course, we're going to change this now to descending for our output. And we want to change the last parameter to descending, so that now, ideally, what we would have is a fourth file in our folder, sample underscore 01 descending.txt. And if you take a look at that one, it should start at 99 and go down to 60. Now, since we've got this working, before we forget, let's go back into our sort version 2, simply comment out the extra noise. And as I said earlier, we'll get back to this particular line, this printf, in a later video. Once we get all of our sorting algorithms working, we're then going to compare the three. And then lastly, we'll build this one more time and we'll run it, and we're back to a less noisy output. Of course, you probably should consider printing out something to the user that lets them know what you did. So hopefully you found this video useful. As always, if you've got any questions or comments, don't hesitate to email me, and thank you for watching.